Alright, so where does glycolysis take place?
Outside of the mitochondria.
And inside the?
Inside, man, I don't even know.
Inside the cytoplasm.
There you go.
So when you draw out a cell, this is a whole membrane, right? And then you have everything on the inside of the cell. The cytoplasm is kind of empty space right there. Okay. So that's where this is taking place.
So is it the same thing as the matrix?
No.
No.
So you have the cell. This is going to be the cytoplasm. Then you'll have things that look like this. That's the mitochondria. And that's where the Krebs cycle is going to take place along with the electron transport chain. Okay. So it's going to be within these, but glycolysis takes place just inside the cell, not in those yet.
Awesome.
Okay. Okay. So we need a certain something to cross into the cytoplasm. What's that certain something?
Do you need an action?
Do you remember?
I have literally
no. So it's just glucose. Glucose is going to combine, right?
Perfect.
And insulin carries glucose to the cell and allows it to go in. So now we've got glucose. Glucose is a 6-carbon molecule. Okay? So glucose is pretty permeable to the cell. It can come, it can go. So the first thing that we want to do is we want to trap glucose into the cell. And the one way we can trap glucose is by attaching a phosphate to the end of it. It's pretty large and it causes it to be polar. So it's large and polar, it has a hard time crossing the membrane. So now it's trapped inside the cell.
And isn't that called phosphorylation?
Phosphorylation, yep.
Okay.
So it's just adding a phosphate to something. And this is how we add it to it. We have ATP come by. So let's imagine the phosphate's not there. So AT comes by and says, oh, we need to trap this. I'll give up my phosphate and become ADP. So this is what we've got now. And now we have a phosphate attached.
Okay, that makes sense.
And that's the first step. So we trapped it, right?
Yeah.
So number 2 is it's decision time. And this is going to be the first decision that's made right here. And we really need to decide if this is going to go through the rest of the process or if it's going to turn into glycogen. And glycogen is just a whole bunch of glucoses attached to each other. And so really what this decides on or is dependent on is if there's plenty of ATP. If there's plenty of ATP, it says, oh, well, you guys really don't need me. So it gives up the phosphate and attaches to glucose in the liver. Right? So it'll travel through the bloodstream to the liver and then become glycogen. But if there's not enough ATP, then we have to keep going on with this process, glycolysis, right?
Yes.
So
it depends on the ATP for decision number 1.
Yeah, it depends on if we need ATP, really. Okay, number 3 is fructose. What's fructose?
Fructose, it's sucrose and, oh my gosh.
You got it backwards.
Okay, fructose is something and sucrose.
So yeah, if you have fructose and glucose, it makes sucrose, right?
Oh yeah.
So this is just the sugar that's found in fruits.
Okay, easy.
So we'll show you how it makes it. So there's a conformational change that takes place when another ATP comes by and gives up its phosphate. It becomes ADP. So we have ADP right here as well.
Okay.
So how much ATP have we used so far?
2.
Just 2, right? So we're in the hole. We've got -2 ATP. It seems super productive, right?
Yeah, very.
It's a time well spent. So this is what we've got. And it looks like I'm spilling out poop. So we've got a long poop, right?
Long poop.
We're going to cut the long poop in half with an enzyme. So enzymes break things down, right?
Yes.
Does your teacher say if you need to know the enzyme's name?
Is this like...
They usually say you don't.
No, I haven't heard it. Maybe he said it, but...
Okay. Oftentimes they're like, don't worry about the names because that's just
Yeah, just
Not
extra.
needed. Yeah, you just need to know that an enzyme comes here, cuts the long poop in half.
Perfect.
Okay? So now we've got a phosphate and 3 carbons for one molecule.
Okay.
And then over here, we've got 3 carbons and a phosphate on the other side. But they're their own distinct particles now that they're broken up.
Are those pyruvates or something like that?
They will be soon.
Yes,
We're working
good.
towards making pyruvate.
Awesome.
Okay? So, a little, I guess, note is it's not just a phosphate and 3 carbons. There's like hydrogens attached and oxygens and other things, but it's kind of complex, so we just write out the real basic
Just stick
stuff,
with that,
right?
yeah.
Because
Right, makes
it gets
sense.
into deep chemistry. Okay, so here's the other thing. We've got this whole cell, right? We're inside of the cell, and there's phosphates floating around, and our goal is to attach another phosphate to this, but where a phosphate would usually attach, there's a hydrogen molecule there. So we want to get rid of the hydrogens so that the phosphate can attach to it.
Okay.
Okay? So we'll just draw a phosphate floating here and a phosphate floating here. They want to attach, but they can't because
Hydrogen.
hydrogen's in the way. So we have an NAD molecule.
This stuff trips me up.
Does it?
Yes.
Okay.
The NAD and the NADH and stuff.
Do you know what NAD does?
No.
It carries electrons. It's an electron carrier.
Easy. Oh, yeah.
So
okay.
it's a taxi cab. We'll talk about a couple taxi
That
cabs.
makes sense. Good.
So he's a taxi cab, and he needs to pick up the people who need a ride, right?
Definitely.
Who needs a ride?
Poop.
Hydrogen,
Cool.
right? Okay. So hydrogen needs a ride, so phosphate can attach. So NAD comes by,
Oh, all right.
and
Turns into NADH.
NADH.
So it picks up the hydrogen so that phosphate can attach.
Yeah. So when this occurs, this is caused. Let me think. So it's caused by dehydrogenase enzyme.
Okay.
But there's 4 things that this loses. It loses essentially 2 hydrogen. So it gives up 2 hydrogen, but NADH only picks up 2 electrons and 1 proton. So in other words, 1 proton isn't picked up. So you'll often see this. This will make sense to you later, especially. You'll see NADH plus H plus. And so all that's saying is 2 electrons were given, only 1 proton was picked up. But they simplify it to just NADH and kind of expect you to know that.
Okay.
Yeah.